Hello, everyone, and welcome back. We are witnessing a new era in artificial intelligence, known as the foundation models era. Almost every AI application you encounter, whether it's generating images, videos, audio, or powering chatbots, is part of this transformative shift. In this video, we'll explore what defines this era, how it's shaping the future of AI, its wide ranging applications, the challenges it presents, and its significance for our future. The first and perhaps the most important question we'll address is what are foundation models? Foundation models are large scale machine learning models pre trained on diverse data sets, enabling them to perform a wide range of tasks. They are called foundation models because they provide a general purpose solution that can be specialized for different applications. Today, terms like generative AI and large language models are being used everywhere, but they are simply components of deep learning, which falls under the broader umbrella of foundation models. Recent advancements and heavy applications of these models have led them to being more popular, but still the idea remains the same, which is rather than training a new model for every application, we can pre train a single model, then somehow adapt this model to solve numerous tasks. Generic models that are used to solve many tasks are referred to as foundation models. Let's break down how this process works. First, we gather vast amounts of data, and this could be text, images, audio, graphs, or code, and then we perform pre training, where the model learns the patterns and rules within this data using unsupervised learning. After that, we adapt the model to solve a variety of specific tasks. These pre-trained models can be reused or fine-tuned for other tasks, saving us from training new models from scratch each time. One common method for adapting a foundation model is fine-tuning it with a supervised dataset. However, more recently, the preferred approach is using zero-shot or few-shot inference, which we'll explore in more detail later. Before 2017, there were precursor models, often referred to as specialized deep learning models. These models, like skipgram, fast text, and word2vec, performed well, but they were designed for specific tasks, meaning they didn't generalize effectively to others and were relatively small in scale. However, in 2017, Google introduced a game changing model called the Transformer, marking the beginning of the modern era of deep learning. Between 2017 and 2019, researchers developed various versions of the early Transformers family, such as GPT, BERT, and Roberta. These models were larger and more adaptable, but they still struggled with performing multiple tasks simultaneously using the same model. After 2019, models became even larger, incorporating more data and advanced architectures, leading to what we now call the foundation model era. These models like GPT-3, Palm, and LLaMA are massive and highly generalizable, allowing them to excel at a wide range of tasks with minimal adaptation. This gives us a basic overview of the three different types of models we've seen so far. By looking at the number of parameters and token count, which for now you can think of as the number of words that the model was trained on, we can grasp the scale of foundation models and why they perform so well. Several factors contributed to this improvement, and everything just didn't happen overnight. For instance, advancements in computer hardware such as GPUs and the development of specialized hardware like TPUs and NPUs made it possible to train larger models more efficiently. The rise of cloud computing further increased accessibility, allowing anyone to access GPUs from anywhere at a reasonable cost, which fueled global contributions to AI development. Innovative model architectures, particularly with the introduction of transformer models and diffusion networks, played a crucial role, leading to a surge in new models that frequently broke state of the art benchmarks. Lastly, data quality and diversity were the key. Techniques like web scraping and synthetic data generation enabled the rapid accumulation of massive datasets, which was vital for training these powerful models. In 2021, a team from Stanford University authored the paper on the opportunities and risks of foundation models, providing a comprehensive examination of these models. The paper was a collaborative effort involving over 100 contributors from diverse fields, highlighting the wide reaching impact and importance of foundation models across various AI domains. The authors noted the sheer scale and scope of foundation models in recent years have expanded our imagination of what's possible. It's clear by now that foundation models have a vast range of beneficial applications for society. In case of language, this model enables tasks such as machine translation, summarization, and question answering with chatbots that seamlessly perform all these functions for us. In the domain of vision, foundation models power capabilities like facial recognition, image segmentation, and object detection. But the impact of these models goes even further, allowing us to combine data from multiple modalities, such as text, images, and audio, for complex tasks like visual question answering, art and design generation, or even image captioning. This ability to generate and analyze diverse types of data is what makes foundation models truly transformative, opening up new possibilities across various fields. Foundation models offer a wide array of benefits. For example, a single foundation model can be applied to a diverse range of tasks, from text generation and translation to image recognition and more. This versatility eliminates the need for multiple specialized models, streamlining development and deployment. The fine tuning process for foundation models requires only minimal task specific data. This means that with a relatively small amount of additional data, these models can be adapted to perform well on specific tasks, making them highly adaptable and cost effective. As foundation models are exposed to more data and larger data sets, their performance continues to improve. The growth in data and parameters contributes to their enhanced capabilities, leading to increasingly accurate and sophisticated outputs over time. Overall, foundation models not only simplify the application of machine learning across various domains, but also offer a scalable and efficient approach to harnessing AI's potential. However, with great power comes great responsibility, and foundation models are no exception. They come with their own set of challenges that need careful consideration. Training and deploying large foundation models require significant computational resources. This includes high performance hardware and substantial energy consumption, which can be costly and have environmental impacts. Foundation models can unknowingly learn and perpetuate biases present in the training data. These can lead to unfair or discriminatory outcomes, making it crucial to address and mitigate biases to ensure equitable and just use of these technologies. The capabilities of foundation models raise various ethical issues, such as misuse for malicious purposes, privacy concerns, and the potential for generating misleading or harmful content. Responsible development and deployment are essential to navigate these concerns and ensure the technology is used for positive and constructive purposes. Addressing these challenges requires ongoing vigilance, transparent practices, and the implementation of safeguards to maximize the benefits of foundation models while minimizing potential risks. The good thing is the potential applications are so vast that every sector and industry is likely to be affected by the adoption of AI in the coming future. Foundation models are evolving with better contextual understanding. Constant effort is being put into reducing size, improving efficiency, mitigating biases, as well as developing fair and transparent AI systems. And there is no doubt that we are firmly in the era of foundation models. These powerful, versatile models are reshaping the landscape of artificial intelligence, driving innovation across multiple domains and applications. From advancing natural language processing and computer vision to enabling groundbreaking multimodal capabilities, foundation models are at the forefront of AI's evolution, setting new standards and pushing the boundaries of what is possible. For further reading, I recommend checking out the papers and articles listed below. You'll find the links in the description, so make sure to give them a read. I'd also like to acknowledge these resources as they were instrumental in making this video possible. Thank you so much for joining me. I hope you found the information valuable and learned something new. If you enjoyed the video, please give it a like and subscribe to our channel. If you have any questions or feedback, don't hesitate to leave a comment. See you in the next video. Have a great one.